Hi, welcome to Dissolved Chemistry. Let us continue our discussion on this equilibrium. In the previous video, we have discussed dissociation of acids and bases, relative strengths of acids and bases in different solvents, and also we have discussed what is leveling effect. Okay. In the present video, we will discuss very important aspect, that is ionization constant of water, constant and ionic product of water. Okay. So prior to going with detail with this particular aspect, so let us consider. See this, when a base is added to water, then how your water is going to behave? Water is going to behave as acid. Okay, as it accepts donates the proton, okay, to the base, and it will form OH minus aqueous. Similarly, when you add acid to water, so then you will see that it is going to act as a base. It will accept the proton to form what? Hydronium cation plus Cl minus aqueous. Right. So this dual behavior of water is due to what? So the question arises. Okay. To explain that, we should go with the ionization of water and ionic product of water, what it means. So that we will see in greater detail. Now consider, if you take 1 liter of water, okay, pure water, if you take, it is found that in that water, so as it can act as acid as well as base, means one of the water molecule will act as acid and another water molecule will act as base to give H3O plus aqueous plus OH minus aqueous. Okay, it means, so to certain extent, water molecule will remain in the dissociated form as H aqueous plus OH minus aqueous. Okay. So 1 liter of water if you take, then around 10 to the power minus 7 moles of water molecule will remain in the dissociated form. Okay. Dissociated form. And this dissociation we will give as capital K, that is equal to, how we will give this one? Molar concentration of H plus into molar concentration of OH minus divided by S2O. And here this K is called, capital K is called dissociation or ionization constant of water. Okay, ionization constant of water, and the water in the denominator, as it is existing in the pure form, so therefore, and apart from that, most of the water remains unionized. So therefore, we will take this as constant. Okay, its concentration is taken as constant. So therefore, capital K is equal to H plus OH minus, and the concentration of the water is taken as another constant K, so small k, and this if you take on to the right or left side, so this is equal to H plus into OH minus. Okay, so this dissociation constant K and another constant which is taken for the concentration of the water, so their product we call it as what? Another constant called Kw, which is equal to product of H plus and OH minus, and this we call it as what? Ionic product of the water. Okay. ionic product of the water at normal temperature, that is 25 degrees Celsius. As I said, 10 to the power minus 7 moles of water molecule remain dissociated form per liter. Okay, so therefore, when 10 to the power minus 7 molecules of water are dissociating, means concentration of AH plus is equal to 10 to the power minus 7, and concentration of the OH minus ion will be obviously 10 to the power minus 7. Okay, so therefore, your ionic product of the water, Kw is equal to what we can call 10 to the power minus 7 into 10 to the power minus 7. So therefore, what it turns out to be 10 to the power minus 14. The ionic product of water is 10 to the power minus 7 and it remains constant. Okay, overall the product of AH plus and OH minus ion is always remains constant. Okay, so we will talk about next. Molarity of the pure water is molarity of pure water. See, when you take pure water, suppose 1 liter of water, we will take 1 liter of water means 1 liter of water is nothing but what? 1000 grams of water. So therefore, if you want to calculate its molarity, the molarity of 1 liter of water is how much? 1000 gram. We will write like this formula. We will write the weight of the water divided by its molar mass. So therefore, weight is 1000 gram and its molecular weight is 18 gram. So gram get cancels. You will be getting 55.55 molar. Okay, molarity of the water is how much? 55.55 molar. Now, when you have 1 liter of water contains dissociated form is how much? 10 to the power minus 7 molecules of water are going to dissociate. Okay, so now therefore what is the degree of dissociation if you want to calculate? So then how you will give? Degree of dissociation is equal to, so number of moles of molecule in dissociated form divided by number of moles of molecules undissociated. Degree of dissociation of water, H2O, pure water if you take, so then how much it will be? 10 to the power minus 7 moles of water is being dissociated and 55.55 moles, molar we can call this, we call as molar, and this is also molar. So therefore, what it will be? It is going to give 1.8 into 10 to the power minus 9. Okay, so is the degree of dissociation of water. As it is acting as both acid as well as base, so therefore dissociation constant Ka, okay, which is equal to dissociation constant Kb, which in turn is equal to what? H plus, okay, by OH minus undissociated form, that is water. So therefore which is equal to 10 to the power minus 7 into 10 to the power minus 7 divided by how much it turns out to be? 55.55. So which is equal to 10 to the power minus 14 divided by 55.55, which is equal to 1.8 into 10 to the power minus 16. Okay, so that is what is dissociation constant of if you consider it as an acid or if you consider it as a base. So then dissociation constant as a acid or base, the value remains same. So that is 1.8 into 10 to the power minus 16. Okay. So this is all about, we have seen dissociation constant, then followed by that ionic product of water, then followed by that, so we have seen the molarity of the water. From that we have calculated degree of dissociation of water, that is 1.8 into 10 to the power minus 9. And then lastly we found that dissociation constant, acid dissociation constant or base, if you consider it as acid or base, their dissociation constant Ka, which is equal to Kb, which is equal to what? So the formula is product of H plus OH minus divided by H2O, and if we find that also, it was turned out to be 1.8 into 10 to the power minus 16. Okay. Next we will talk about the pH scale. Okay. So what it means, so that we will see. The hydrogen ion concentration. Okay. So that we are going to measure in terms of what? The pH scale. The hydronium ion, that is H3O plus, okay, its concentration is in molarity is measured in terms of logarithmic scale. Okay, and that logarithmic scale, how we are going to measure? So we are going to define it as what? So pH is equal to, so negative log to the base 10. Okay, so the activity of a hydrogen ion to define, but we know that, okay, so activity when the concentration of H plus ion is less than 0.01 mole, so then the activity will be always is equal to the molar concentration of the H plus, okay, that is moles per liter. Okay, so therefore, so how we are going to define now? The pH is equal to minus log to the base 10 the molar concentration of the H plus ion we call, or hydronium ion concentration in the given solution. Okay, so now this pH scale ranges from, as we know that the ionic product of water is 10 to the power minus 14. So therefore it ranges from 0 to 14. The scale is from, okay, it starts from 0, okay, and it will end to the 40. The pH scale, okay, so 7, it is the middle pH. So we will take, this is pH, and below we will take H plus ion concentration. Okay, so we'll put like this, 10 to the power minus 1, 10 to the power 0. So here we will write 0. This is 1. Okay, so 12, 13 and 14 we will take. So then the concentration of the H plus ion will be given as 10 to the power minus 2, 10 to the power minus 3, 10 to 12, 10 to the power minus 13 and 10 to the power minus 14 we will take, right? So as this hydrogen concentration, say for example, if the H plus ion concentration is equal to 10 to the power minus 2, means your pH will be 2, and which we call it as what? Acidic pH. When its concentration is exactly equal to 10 to the power minus 7, as we know that one, that is pure water if you take, so then its pH will be always 7. Okay, so therefore we can conclude from this as, if the pH of the solution is less than 7, then we call it as what? It is called acidic pH, means hydrogen ion concentration is high. Okay, then what you call your water. The next is pH is equal to 7. If it is, then we call it as what? Neutral pH. And if the pH is greater than 7, okay, so then it is called basic pH. Okay, now for example, you can take if the OH minus ion concentration, okay, it is equal to 10 to the power minus 4 if you consider, then we know that from ionic product of water, so which is equal to what? H plus into OH minus is equal to how much? 10 to the power minus 14. Okay, so therefore, when OH minus ion concentration, if you say 10 to the power minus 4 means, so what it turns out to be, H plus ion concentration will be 10 to the power minus 14. Okay, right? Then if you take, so then it will be divided by 10 to the power 4 minus 4. If you take onto the top, then it will be turning out to be 10 to the power minus 10. So therefore your pH will be how much? pH is equal to minus log of 10 to the power minus 10 means it turns out to be how much? 10. Okay. So when the concentration of the OH minus ion is 10 to the power minus 4, so then pH of the solution is 10. Okay. So that we call it as what? Basic pH, which is clearly indicated that the concentration of the OH minus ion is high when compared to concentration of the H plus ions. And the scale why it ends at 14, the reason is the ionic product of the water is 10 to the power minus 14. So therefore, if you take the value, pH value, so then the highest you will be getting what? 14. Okay. So that is why the scale is winding up at 14. Okay. Then next is we will see other logarithmic values. Okay. Terms we will see other logarithm terms. So that is Kw is equal to H plus into OH minus ion. Now what you do? Multiply with minus log. So therefore minus log Kw is equal to minus log of H plus into OH minus. Okay. So now you calculate H plus ion concentration is anyway we will multiply this log of H plus minus log of OH minus. Okay. Minus log H plus meaning is what? pH plus minus log of OH minus means POH, and we express this as what? pKw, which is equal to pH plus POH. So therefore your value pH it will be always what? How much? 7. Okay, and POH will be 7. So therefore which is equal to what? 14, or we can write like this. Okay, minus log of 10 to the power minus 7 plus minus log of 10 to the power minus 7. So therefore that turns out to be 7 plus 7. So therefore your pKw value will be 14. So therefore your scale is devised as 14. So this is in this way also we can say that the value of this pKw is very important to express the concentration of the H plus ion and OH minus ion. Okay, so it plays very important role, pKw. Okay, so this is how we are going to explain various aspects of the water and the pH scale, how we are going to measure the concentration of the H plus ions. Okay, thank you for watching. Please subscribe our channel. Thank you.